So welcome back. This is probably the last topic which we are going to cover in this course, and this is related to the landforms developed by wind action. So basically what we call that as an aeolian or aeolian. Either you say E-O-L-A-I-N or aeolian. It's just a matter of the words, but the landscape remains the same. So what you see at the background here in the first photograph is the cold desert. So we'll be looking at some examples of the deserts from different regions or the continents around the globe, and I'll also try to show you a couple of satellite data, couple of slides from India also. So let's get started. So what you see here is mainly, as soon as we talk about the aeolian landforms, the first thing which comes in our mind is sand dunes. So the best location in India to view or to enjoy the desert or admire the sand dunes is your Rajasthan. So this is another picture of the sand dunes, and this photograph is from, as I told, from the US, and this area is named as Great Sand Dunes National Park, Colorado. Now when we talk about the wind as an agent, then there are three main important points which comes in mind. Is that wind action will result into erosion, and if erosion is there, again very much similar to what we discussed in the fluvial systems, that erosion, transportation and deposition. So here also the wind as an agent will erode, transport and deposit. But there the water was the agent, here the wind is the agent. So this is the only difference between the two. So further, if we look at a few important points, so if we say wind is a term, it is termed as a geomorphic agent in all terrestrial environments. Wind act as an agent that erode, transport and deposit the loose surface material, whichever is available to it on its way, which are mostly the areas, the erosion will be extensive in the areas which are devoid of vegetation. So it is a powerful in dry areas, dominant with fine grained soil and sediments and little or no vegetation. So mainly the action, that is we are talking about the wind action, will be extremely dominant in the region where the sediments are loose and fine grains, not the coarser deposits. But if you are having fine grained soil which is barren, not covered with the vegetation, so the wind action will be extremely dominated or it will be powerful. The extensive sand seas and grooved bedrocks in the world's arid region attest the potency or power of aeolian processes. So like the wind action can also erode the bedrocks and it can groove the bedrock. So it is one of the powerful agent, or the process, aeolian processes is quite powerful in eroding the landscape and sculpturing the landscape. More local effects of wind action are seen along sandy coastline and over barren fields and in alluvial plains. So if we consider this in context with India, then we will be able to pick up the wind action as well as the aeolian landscape, though it may not be in complete desert, but you will be able to see the development of the landforms related to the aeolian activity in the coastal areas, as well as in areas where the area is bare, like devoid of vegetation. It could be either the areas close to the river banks where the channels have tendency to migrate, or areas marginal to glacial. So as I was talking about the cold desert, so again in that region you will come across where the landscape is totally barren. The wind action will result into the sculpturing of the landscape. It can erode the bedrock, erode the material, transport the material, fine deposits as well as coarse deposit, and result into the deposition and the formation of the landscape. Now, distribution of the desert across the globe, you will be able to notice that in the middle part of the globe, that is, we are talking about the tropics, you will not be able to see much of the desert formation. Locally, as I was talking about, you can come across in the areas like coastlines where the rivers are migrating, that those areas can also still show the local deposition by the wind action and all that. But mostly the overall distribution, if you look at, then you see in an areas which are hyper arid as well as arid region, but in semi arid regions you will not be able to see much of the formation of deserts. So, distribution of desert around the globe. Deserts are regions with very low rainfall, and the rainfall ranges less than like 300 millimeter, meager vegetation, extensive barren land that covers about 1/3 of Earth's land surface. So, deserts are also extensive, and it is not that we see the deserts in a very limited pockets, but it covers about 1/3 of Earth's land surface. Many deserts are hot or tropical, but some are polar, in the polar regions also. So, you have cold desert areas, including Antarctica, are desert because they are cold and dry. So, most of the deserts are hot, or you can say in the tropic or subtropic regions, but some are in the areas where we are having glaciers. So, it is cold and dry. So, deserts are classified in 3 categories based on the rainfall. Extreme arid areas with at least 20 consequent months without rainfall. So, throughout the year the area experiences a dry phase. Then comes, that is, you can classify that as in hyper arid areas. The arid regions are the areas which are having the rainfall, that is an annual rainfall, less than 250 millimeter. So, based on, because the rainfall is less, vegetation will be very sparse, and most of the areas will be exposed to erosion. So, when you say that the rainfall is less, of course, the water is not so much available as an agent. So, wind action will be more dominant in such regions. And then third is semi-arid regions with a mean annual rainfall which ranges between 250 to 500 millimeter. So, these are the 3 areas, and based on this rainfall pattern, one can classify the deserts, and mostly the deserts you will see that the extensive deserts are in hyper arid areas. Further, if you look at the globe, then we have the north and south poles, we have polar areas, and then gets into the temperate subtropical deserts on either side on the southern hemisphere as well as the northern hemisphere, and then we have the tropical in the center, and then semi-arid on again on the other side of the equator. So the reason here is very simple, is the rising air at the equator loses its moisture by raining, and this rainfall is mostly seen in the rainforest area, and then what we have is when the air sinks over subtropics, it warms and absorb water. Thus rainfall is rare in subtropical areas. Main cause for the formation of desert is the rare rainfall in the subtropical areas, and this is because of the absorbed water, whereas in the tropical regions the rising air loses its moisture, giving rise to the rainfall. So these two are the main reasons for the location or the development or the formation of the deserts in subtropical areas, mainly in the northern as well as southern hemisphere. These are the major deserts or the distribution of desert around the globe. So if you want to see the extensive one, which has been shown here, is your Sahara Desert, and then on the northern side you have the polar desert and so on. Okay. And this region, I'll show a couple of 1 or 2 slides on this. This region is your Great Indian Desert, that is termed as Thar Desert. Now this is another important factor which will play a key role in development of desert on the leeward side of the mountains with respect to the wind direction. Suppose you are having a landscape within coastal area which has been shown on your left, and the moist air which picks up the moisture from the ocean through evaporation will flow towards the land. So the rising air, because of the orogeny or because of the effect of the mountains, will rise and air cools down and result into the rainfall. But when the air crosses the mountains, it is dry, and that is what we call the rain shadow zone. So moist air cools down when forced to rise by mountains. This is in particularly in this area when the moist air comes here from the ocean, and so it will result into the rainfall. So the moisture condenses and rain falls, nourishing coastal rainforest. So by the time the air reaches the inland side of the mountains, it no longer holds enough moisture to rain, and that's what we call the rain shadow area. And this graph which shows here is the rainfall centimeter per year, and as you move away from the mountains or on the backside of the mountains, then you have very low rainfall. So maximum rainfall is over here, that is close to the mountains and the foothills. There is no very less amount of rainfall. So graph shows the variation of rainfall from the coast across a mountain range and into the rain shadow region. So this is also one of the reason, if we consider the topography, which plays an important role. So this is what I was mentioning about the desert. The Great Indian Desert is this one, which marks the boundary between India and Pakistan. Here, this is the border, in Gujarat, and this side is Pakistan. So this landscape is the Great Indian Desert, or you can say the Thar Desert. Another photograph of that. So this is an satellite image, false scale composite image of the region. So this pattern of the landscape is indicative of desert. That is what we call as in Thar Desert. Now wind action and processes. So there are number of patterns in which the transportation of material will take place. Either it is in suspension, in saltation, reptation, creep. So there will be number of pattern in which the material will be transported, and this again will depend on the energy condition of the wind as well as the material which has been carried, that is the size also, because you cannot expect and complete blow or saltation or the transportation of the coarser material. So let's see the different wind action and processes which are involved in terms of transportation. So wind transport encompasses 4 processes. So one is saltation. Now saltation is a motion of sand grains confined to a short distance, where the material is transported for a short distance and lifting of the grain at a height of about 2 meters from the surface. So when the sand grain is dropped on the surface, it rebounds and impart renewed energy to another grain. So if you drop some material from an elevation, and if you are having on the ground surface which has a cover of thin sand cover, then you will have that the few sand grains will blow off where you have dropped the material or any stone or anything. So this is the same process which has been talked here, is that it imparts renewed energy to other sand grains. Now coming to another process of transportation is reptation. Now this is on hitting the surface, saltating grain release a small splash of shower. That is, when you drop one grain, it will result into the other grains to move from that location. So shower of the particles that makes small hoop like features. So this was been shown here. So if you see the saltation, then this is what is taking place, or reptation. Okay. So when you drop one grain here, then you will have the sparkling or the movement of the grains from that particular point. That is your reptation. Suspension. Particles of silt and clay size lifted in the atmosphere become suspended and may be carried for a greater distance. Now in case of this too, where we are talking about a short distance, and this also is just an hooping from one place where the previous grain is hitting the surface, its movement is not for the very long distance. But if you look at this one, this is a fine grain, silt and clay. So if the wind action or the wind energy condition is very high, then it will result into the lifting into the atmosphere, and it will be transported for a greater distance. Now fourth one is creep. Now this will happen in case of coarse sand and small pebbles. So even the pebbles or you can say the gravel of pebble size can be moved forward by rolling and sliding. So once the material gains the momentum from the impact of jumping sand particles, it can be slided. Okay. So it can roll or slide. So coarse sand and small pebble moved forward by rolling and sliding with the momentum gained by the impact of jumping sand particles. So this will come from reptation. So the four processes should be kept in mind, which will be very commonly observed in the desert area, and these processes are responsible for transporting and depositing the material ranging from pebble size to silt and clay size. Further, wind erodes dry, bare, fine grained soils and sediments. It is most effective in deserts. So wind erodes mainly the dry material, okay, and this is more effective in deserts, sandy coast and alluvial plains next to glacier. Particles transported by the wind bounces, that is what you call saltation. It hoops, reptation, floats, suspension, and roll and slide, which is we call in creeping. Now, because of the different action or the wind transport or the processes, transport processes, different landforms can be formed. Okay, we will discuss few here, where the most common, as I was talking about, that as soon as you talk about the desert, then you say that, oh fine, it is the desert will be comprising of sand dunes. Okay, but there are many which are seen or observed in the areas where you are having different material which are transported by the wind. Okay. So several landforms are product of wind erosion. Examples are lag deposits and stone pavements, deflation hollows and pans, yardungs, zugen and ventifacts. And we'll see few of them. So sand accumulation, if we take in terms of the size of the landforms, it can result into the different categories. One is very small, you can say ripple marks or the ripples which are formed for this by the wind action. Then you can have dunes, you can have dune fields, or you can have sand seas. Okay, so extensive desert. And then another what we see usually is the dune may be grouped into free and anchor types. Okay, either the dune can keep moving, or they are anchored to any vegetal cover or so. So we will stop here and continue in the next lecture. Thank you so much.